Hello guys, this is Dr. Possibility from Excel Academy. Kindly make sure that you subscribe to our YouTube channel and make sure that you register with Excel Academy. In this tutorial, I'm just going to explain on vectors. So when we talk of vectors, these vectors, what are they, or what are the component of vectors? In short, what are we trying to discuss when we talk about vectors? But before we talk about vectors, we need to understand the branch of science, which is physics. So when we talk of physics is the branch of science that deals with measurement. So when we talk about these measurements which we are trying to consider, we can simply talk about the length, we can talk about the weight of something, how heavy something is, and we can also simply talk about time. But before we go in detail and look at this content, so it is very important for us to just pick one thing at a time. And in this case, we are just going to consider the measurement of length. So when we talk of the measurement of length, we are just simply trying to consider the distance between two particles or two things. The other thing that you need to understand when we are talking about the length, we are simply trying to measure the magnitude, okay? We are simply trying to measure the magnitude and also the direction. So in other words, when you talk about the magnitude, we are simply talking about the what? The size. For example, you can talk about what? 4 meters. So when we say 4 meters, we are simply talking about the size of length, the size of that particular distance. And then the direction in physics can either be the angle, or you can just simply talk about things like north, south, east, west. So all those, they just simply talk about the direction. So sometimes we might consider the angle as the direction. Okay. So with that in mind, before we go much in detail about what vectors are or how you can measure the vectors, we need to understand an important quantity in physics, and this quantity is just the what? The scalar quantity. So when you talk of a scalar quantity is a quantity that just has what? Magnitude. It only has the magnitude. It only has what? The magnitude. That means that when you are considering, let's say someone moves from one point to another, we are not going to talk about in which direction did they move. Instead, we are just going to consider how much distance did they cover. Did they cover 4 meters? Did they cover 5 meters? We are not going to consider in which direction did they move. Okay, so when you talk of a good example of a scalar quantity, you can consider what? Distance. So distance is just the length of the actual path taken by an object. It's just the length that an object has taken. For example, let's say an object moves from this particular point and goes to another particular point. Okay, let's say an object moves from point A and goes to point B. Okay, let me repeat that. So distance is just the actual length that an object takes. Okay, in this case, let's say an object has moved from point A to point B, and this distance which has been covered is just what? 20 meters. So when you talk of a scalar quantity, it's not talking about in what direction has this object moves. Instead, it is just considering how much length has been covered. Okay, so in this case, if an object moved from point A, to point B, 20 meters. Okay, now one thing you need to understand when you're talking about a scalar quantity, we only talk about the what? The units. You only talk about the what? The unit and the what? And the number, of which this unit It can be in meters, it can be in centimeters, it can be in kilometers. But in physics, it's very important for you to just consider the what? The SI unit. So when you are doing your calculations, make sure that the units are in the SI unit. So when you talk of distance, the SI unit of distance is just what? The meters. So if you have been given something in centimeters, you need to change it to meters. So a scalar quantity, like I have stated, it is a quantity that has only what? The magnitude. It is the quantity that has no direction. So when you move from point A to point B, we are not going to consider in what direction did this guy move. Okay, we are just going to consider the actual path that was what? That was taken. So like I've already said, a scalar quantity contains only the what? The magnitude, only the size. It doesn't have the what? It doesn't have the direction. A good example of a scalar quantity is the what? Is the distance. On the other hand, we can simply talk about the vector. Okay, so since we now have an idea on what a scalar quantity is, we now need to understand the other part, which is what? A vector. Okay. So another part of length which you can consider is the displacement. Remember, we have the distance, which is talking about the actual path, but we also have what we are calling the what? The displacement. So the displacement is an example of a vector quantity. So when you talk of a vector quantity has both the size, it has both the size and what? And direction. It has both the size and the what? And the direction. So it's very important for us to know that the difference between a vector quantity and a scalar quantity is that a scalar quantity has no direction, but a vector quantity has what? Has direction. So a very good example of a vector quantity which we can consider is displacement. So a displacement is the straight line separation of 2 points in a specific what? Direction. That means that this displacement is having an added content, and this added content is just the what? The direction. And in most cases, the direction is shown by the what? By the arrow. So remember, we had this situation whereby a point moved from an object moved from point A to point what? To point B. Okay, and the path we had to consider was this white path, and this white path was just demonstrating the what? The distance. But on the other hand, when you talk of displacement, we are not going to consider the actual path. We are not going to consider this actual path. Okay, so the yellow part is talking about the what? The distance. But when you talk of the displacement, it's going to have the what? The line which is separating 2 points. So the line which is separating this point to that point in this direction. So remember, this theta is just telling us what? The direction. The theta is talking about the what? The direction. So when you talk of a vector quantity, as you deal with vector quantities, you need to know that one, you need to measure the what? You need to measure the size, and also to measure the what? The direction. So in most cases, when you talk of the direction, we're just simply talking about the what? The angle. So the angle just simply talk about the direction. For example, in this case, the angle here is just 20 degrees. So that means that this object moved 12 meters. Okay, it moved from point A to point B 12 meters in the direction which is what? 20 degrees. We'll go much in detail in the next content. So when you talk of a vector quantity, remember, a vector quantity has what? Has the direction and the magnitude. And when you talk of the magnitude, like I've already stated, a magnitude is just talking about the size. And the direction, it can be the angle or it can be north, south, east. But in most cases in physics, we normally talk about the angle. Then, as you are writing a vector, you need to consider three things: the number and the unit and also the angle. So the number and the unit are making up what we are calling a scalar quantity. But for a vector, there is an added thing, which is the what? The angle. And this angle is simply talking about the direction. For example, you can talk about 12 meters, 30 degrees. So when you talk of 12 meters, 30 degrees, it simply means that this object moved 12 meters from here to there, and then the direction was the 12 degrees. Then for this one, which is 8 kilometers per hour north, that means that the object moved 8 kilometers northward. Okay, let's move on and stay focused and pay much attention on the same thing, which is distance and displacement. Remember, distance is talking about the scalar quantity, but when you talk of displacement, we are simply talking about the vector quantity. So when you talk of displacement, which is a vector quantity, you need to understand that this guy has to be put in the what? In the XY coordinate. So when you are sketching your graph, you need to consider the negative side, the positive side of a given graph. Okay. Why? Because it has to deal with the what? The displacement. It has to deal with a vector quantity. It has to deal with the direction. That simply means that vectors can be added or subtracted. So a very good example we can consider when you talk about the displacement or the distance and the distance. Let's say you talk about a car that travels 4 meters east, then 6 meters west. So a car, we are considering a car. For us to understand how displacement and distance can be applied, we can simply consider a car that is traveling 4 meters east, then 6 meters west. Okay, so look, one thing we need to understand is that we have a compass. Okay, we have a compass. So you need to know that up is north, then you have east on your right, west on your left, and the down it is what? It is the south. So let's quickly look at this car. So you have the y-axis, which is this side, and the x-axis. Remember, this is the north, this is the north, and then this is the north, and then this is the east. There we have the east, and then this is the what? The west. Okay, so according to the example we have, we are saying we are considering a car that travels 4 meters east, then 6 meters west. So this car has moved 4 meters east, meaning it has gone this side 4 meters, and then again it has moved this side what? 6 meters. So the question is, what is the displacement and what is the distance? So when we talk of the displacement, since this car moved 4 meters going this side, okay, since it moved 4 meters going this side and then 6 meters going that side, so the first meter was going east, and then the 6 meter was going in the opposite direction. So for you to know the displacement, you need to subtract. For you to know the exact displacement, since we are considering the vectors, you need to do what? You need to subtract. So we are going to say the net displacement, since it moves 6 meters this side, which is in the opposite direction of 4 meters, then that means that you can just say 6 minus what? 6 minus 4 meters. And the answer is simply what? 2 meters west. Remember, the resultant is having the west side, okay? It's on the west side. That's why we are saying 2 meters west. So according to the displacement, since displacement, it depends on the what? It depends on the angle or direction. So this object simply moved what? 2 meters west. You just simply subtract 6 minus what? Minus 4, and this is simply what? This is simply 2, because west it is 4, and then west it is 6, and then east it is 4. Then if you talk of the distance, the case is different, because distance, we are talking about the actual distance covered. So in such a case, when you talk of distance, it is just 6 plus 4, and the answer will simply be what? 10 meters. So this is one of the differences between a scalar quantity and also a vector quantity, because a vector quantity, it depends on the what? On the direction. As a result, we had to subtract there. This side is the opposite of that. With that being in mind, we just say 6 minus 4 for us to have the displacement, which is a what? A vector. Remember, this is a vector, this is a vector, okay? And then the other one is just a scalar. So for a scalar, you just simply add. Okay, let's move on and look at one important thing, which is under vectors. So one thing that we need to understand when we are dealing with the vectors, okay, of which a very good example of a vector is what? Is the displacement. So one thing that we need to understand when you are dealing with vectors is how to identify the direction. You need to know, is the object moving in the north, south, east, or west? Okay. Now, quite all right, it is okay for you to know such, but we also need to understand at what angle is this object moving. So let's quickly look at something very important. So a common way of identifying direction when you talk of a vector is whereby you consider the east, north, west, and south. But remember, the direction can also be the what? The angle. So it's not really necessary for you to only know that direction is about east, north, west, and south. No, you also need to consider that the direction can be what? The angle. But in this case, we're just going to consider north, south, east, and west. Okay, let's quickly look at some few examples, some few content. So the first one, like I have stated, the best way you can identify vectors, the direction of a vector, is by considering north, south, east, and what? And west. Okay. Now, let's look at this particular particle. Let's quickly look at this particular particle. So this is the origin. 0 here is the origin. And assume a particle moves from there to there. What could be the direction? What could be the direction? So if we assume that the length of this particular particle, which has moved from that point to that point, is 40 meters. So what is the direction? What is the direction here? So the direction here is just simply what? 40 meters, comma, 50 degrees north of east, because this is north and then that east. So north of east. So in some questions, they will just say north of east. So you, as a student, you should be able to know, okay, which part is having north and the east. So if you look at this, this is 50 degrees, which is the angle at which this object had moved, and the direction is simply the north of east. The other one we can try to consider The other one we can try to consider is that particular point. So that point is just 40 meters 60 degrees north of west. So you have that particular point which has moved. Remember, we have considered this length to be 40 meters. So the angle here is 60 degrees, and then the direction is just simply north of west. Okay, let's move on and quickly consider another point. So let's look at that point. So that point is that, and then that one is also like that. So if you look at what are we really considering, so when you are using the quadrant, so this is the first quadrant, the second quadrant, third quadrant, and the fourth quadrant. So when you are calculating in terms of vectors, the angles you need to consider, you need to make sure that you are very, very careful, taking note of the quadrant, taking note of the angle you are trying to pick. But in this case, we're just talking about the direction. For such cases, I am going to explain. So just a recap. So when you talk of the origin here, so the first object which moved from that point to that point at an angle of 50, this object, the direction is north of east, and then this one, it is north of west, then this one, it is west of south, and then that one is south of east. All those are just giving direction. Now, if you observe very well, you need to understand that we are also considering the angle. We are also considering whenever we are dealing with direction, we are also considering the angle. So it's very important for you to write the angle just the way we have indicated at that particular point. Okay, so make sure that you are able to identify the angles. Like in that case, those are just the answers for that particular question or vector. So here you need to understand that the answer for this vector is just 50 degrees south of east, and then this one is just 45 degrees west of north. So it's very important for one to be able to consider such cases. Okay, let's move on. So we also need to understand that the polar coordinate way is the best way you can express vectors. For example, you can consider a vector of 40 meters 50 degrees north of east. So how can you consider, okay, how can you consider, or how can you write this vector? Remember, r is just talking about the resultant, and then theta is just talking about the angle. So we are considering a vector which is having 40 meters 50 degrees north of east. So how can you sketch such a vector? So guys, it's very important for you to change, let's say, a statement into a diagram, because in physics, before you solve, you need to have a free body diagram. So that free body diagram is the one which is simply guiding you, which is giving an overview on your approach on a given question. Okay. So we are considering the vector which is 40 meters 50 degrees north of east. So how can this vector look like? So this vector will simply look like that. So let's say we have the angle from here to there, it is 90 degrees, like I've stated. Then from there to that particular, that which is 180, then from there to there it is 270, and from the complete cycle it is just a 360. So this vector is simply 40 meters north of east. 40 meters north of east. So how can you express such a guy? So let's try to look at that. So this is just the length, which is 40 meters, like you have seen, 40 meters. And then there on top we have north. Okay, there we have north, and then there we have east. So since we have north and then there is east, so that means that this vector has to exist within this region. So the magnitude, which is the size, it is 40 meters. And then remember, the size need to have a number and also the unit. Then the angle which has been at which this object has moved is just 50 degrees, which is also part of the direction. Then if you look at this, there are two content which have been considered. So I'm just trying to explain what the polar coordinate mean. So if you look at this, there is two content which we have illustrated. We have illustrated 40 meters and also 50 meters. So we can assume, let's say this object moved this path. So let's say it moved like that, okay, like that, and then it went up like that. So this is the resultant, isn't it? So it moved from there in the x-axis eastward, and then it went upward in the y-axis, which is what? Northwise. So this guy, which is this 40 meters, it is just simply talking about the what? The resultant. So this is the resultant, okay, and then this is the angle. So this 40 meters is representing the resultant, which is what? Which is r. And then this 50 degrees is just talking about the what? The angle. Okay, so with that in mind, I can simply use the other diagram, of which I've said r is just the distance, which is the magnitude, and it has the number and also the unit. So from there to there, it is r, which is the resultant. So if we were to assume two vectors, like I've said, one vector moves from that point, okay, this object moves from here, and then after it moves from there to there, and then it goes up like that. So for distance, we are going to say from here to there, and then from there to there. But we are not talking about distance. Instead, we are talking about the what? The displacement. In such a case, we are going to look for the resultant. And this resultant is the shortest possible distance between two objects. So if you look at that particular point and that particular point, you're just going to move from tail to head, and then you're going to have the what? The resultant. So a vector has the resultant part and also the direction part, and the direction is simply the what? The angle. Okay, let's quickly look at some few examples when you talk of the polar coordinate way of showing the vectors. Remember that the Cartesian plane has angles, okay? So from 0 to 90, it's simply talking about the first quadrant. Then 90 to 180, it is the second quadrant. 180 to 270, it is the third quadrant. And 270 to 360, it is the fourth quadrant. So let me quickly look at some few points which you can consider. For example, so if you look at this particular point which has moved from 0 to that, so remember, let's say this point moved from that point, went there, and then went up there. Okay, so from there to there, then it went up there. It really didn't go direct like that. Instead, it moved two steps. It moved from there, went there, and then lastly went up there. Then you connect these two to give you that simple displacement. In such a case, the resultant, which is r, like we have considered it to be 40, this guy will be from there to there, which is 40, and the angle will be 50 degrees. And this is in the what? In the first quadrant. So if you observe very well, For the polar coordinate, we are not considering northeast, southeast, or west-south. We are not considering that. Instead, we are just simply considering the magnitude and also the angle. So let me quickly look at the second quadrant. So let's say you have that object there, and this object is moving 60 degrees, isn't it? So this guy has said 60 degrees in the second quadrant. But when making calculations, it's very important not to consider the 60 degrees. Why? Angles in vectors, we move from right going what? To the left. We move anti-clockwise. So you need to move anti-clockwise. So if the angle in the second quadrant, sorry, is 60 degrees, you don't have to consider that 60 degrees. Instead, you need to consider the what? Then the answer you get when you subtract 180 minus 60. So you're going to say 180 minus 60, and this will simply give you 120. So remember that you don't consider that angle for the second quadrant. Instead, you consider the other angle. And one thing I've taken note is that angles in vectors, we don't move from left to right, because in vectors we normally move anti-clockwise like that. So when you have such a vector, you're not going to consider that angle in the second quadrant. Instead, you're going to consider that angle, because angles in the second quadrant, we normally move from right to left, and that is anti-clockwise. Magnitude will still be the same. Let's consider the third quadrant. So the third quadrant, let's say we have 40 meters. Remember this, let's say it is 60 degrees in the third quadrant. So you're not going to consider that 60 degrees. Instead, you're going to say 180 plus whatever value you have. So in that case, you can simply consider that other value, which is just 210. Remember, don't consider the clockwise one. Consider the anti-clockwise. Please take note of that. Then the fourth quadrant, let's say we have that guy there, that particular point. So in such a case, you are not going to consider the 60. Instead, you are going to consider the 300 degrees. So that's it when you are talking about the vectors. Okay, let's quickly look at the rectangular coordinates. Let's quickly look at the rectangular coordinates. So we have only considered the polar way, and we have also considered the one for northeast, southeast, like that. But this time around, let's now look at the rectangular coordinate way. So this one is whereby you have an object, and this object it normally moves in a systematic way. Okay, for example, so when you talk of the rectangular coordinate way, this one will help you to know, are you subtracting the given vectors or are you adding the given vectors? That's why we are having the negative 2, positive 3. Meaning in this case, this area, okay, I'll start with this one. North and east, you only expect the positive coordinates, isn't it? So north and east, you expect the positive values. +3, +3. +3 is for the x-axis, okay? And then this one is the y-axis. This is the y-axis. Then for the other one, if you look at this side you need to expect the negative and the positive, of which x is negative and then y is positive. So this is very important when we are going to be talking about multiple vectors. The finding the resultant of multiple vectors. This is why we are now going to consider the x coordinate vectors and also the y coordinate vectors, and then we come up with the what, with the resultant. And then after that we also need to consider the given angle. Let's say we come up with a given angle, and that angle, how are we going to determine? Is it in the first quadrant, second quadrant, third quadrant, or fourth quadrant? So these coordinates are very important. So in the third quadrant, both the x and y coordinates are what? Are negative. And then in the last quadrant, which is the fourth quadrant, the x is positive and the y is negative. Okay, let me give a summary of something which I've stated. So like I've stated, when you're moving toward this side, you expect x to be what? Positive. When you're moving this side, x is positive. You're moving that side, y is positive. You're moving this side, x is negative. You're moving downward, y is negative. So the summary is, right up, it is positive, right up. So meaning we are talking about this particular area. Right up, both are positive. Then left down, which are negative. So this side, it is the x-axis, which is negative, and then the y-axis positive, and then this one, the x-axis is positive and the y-axis is negative. All right, guys, when dealing with vectors, another aspect that you need to consider is also the trigonometry. So when you are dealing with vectors, another thing that you need to consider is trigonometry. So this is where now we are now considering the angle, which is the direction. So in this case, we are trying to understand how can trigonometry be applied when it comes to vectors. How is trigonometry applied when it comes to vectors? So consider the three ratios which we have. Okay, we have three important basic trigonometric ratio. We have the sine, cos, and tan. And in this case, we are going to get a right angled triangle, and this right angled triangle, it has the y coordinate and the x coordinate, of which we are considering this to be our theta, which is our angle there. So sine, cos, and what? And theta and tan. So if we get sine, what will be the ratio there? If we get sine, remember this is the x coordinate and that is the y coordinate, okay? Or in other texts, this will be the opposite, okay? This will be the opposite. This will be the adjacent, okay? This will be the adjacent, and this will be the what? The hypotenuse. So if you consider the sine ratio, you need to understand that sine is equal to, sine theta is equal to opposite over what? Hypotenuse. Meaning the ratio for sine, it will be sine theta is equal to y over r. So to find the value of y, you're just going to say y is equal to resultant sine theta. So in this case, the hypotenuse, it is the what? It is the resultant, because this vector has moved from that particular point, it goes that way, okay? It goes that way, and then it goes up like that, okay? So this is the movement of this particular vector. It has moved from that point to that point and then to that point, and the angle is what? Theta. So for you to find the y coordinate or the resultant, you need to use the coordinate sine theta is equal to y over r, of which r is the resultant, the one I've already explained, and then y is just the y coordinate. This is a case where you have been given let's say the resultant, then you have also been given the angle, and then you are asked maybe to find the y coordinate. So how can you find the x coordinates? So the x coordinate, you need to use cos. So the x coordinate, you are going to use cos. So when you are trying to apply trigonometry, one thing you need to consider is the y coordinate can easily be found by using what? Sine theta, okay, and the resultant. And then when you talk of the x coordinate, you can simply use cos theta. What about in a case whereby you have been given the x coordinate and the y coordinate, and then you want to look for maybe the angle or the resultant? Okay, let's say you have, because the major thing to find in vectors, it is the resultant. So how can you find the resultant when you only have the x coordinate and the y coordinate? So in such a case, you just first find the values of those guys. So in terms of the angle or the direction, whereby you are only given the x coordinates and the y coordinate, or you are given the x direction and the y direction. So if you have been given the values, to find the angle, which is this one, you can simply use tan. So tan theta is equal to y over x. And for you to find the resultant, you can simply use the Pythagoras theorem, which says r squared, the hypotenuse, is equal to x squared, which is the adjacent, plus the y squared, which is the opposite. This is only applicable to vectors that are moving using the right angled triangle. Okay, with that being said, let me quickly look at how the exam or test or quiz is set and how you can apply what I've just explained. So the example is, find the height of a building if it casts a shadow 90 meters long and the indicated angle is 30 degrees. So in such a case, you have been given the building. So this is the building, isn't it? So this building has the height, okay? This building has the height, this one, which is the height, and this building has cast a shadow which is 90 meters, okay? This is a shadow which is 90 meters. And then the angle at which this building has cast that guy, it is what? It is 30 degrees. It is 30 degrees, which is the angle. Now, what we are looking for is the height of this building. So I'm sure you guys can try to find what the height is and how you can find the height. So in such a case, it's more like we have been given this as the x coordinate, this as the x coordinate. The resultant we don't have, isn't it? We don't have the resultant in that case. So how can you find the height? How can you find the height? So one thing we need to consider is that the height h is opposite 30 degrees and the non-adjacent side is 90 meters. Remember, they have to be in the SI unit. So this is the adjacent, this is the opposite, okay? So for us to find the height, we need to look for the ratio of trig which has the adjacent and opposite. So the ratio of trig which has adjacent and trig, the adjacent and the opposite is only the what? The tan. So we are going to use tan theta is equal to opposite over what? Adjacent. And you need to know that the opposite is just the what? The height, and then the adjacent is just 90 degrees. When you work out this and make h the subject, the formula, you're going to have h is equal to 90 meters tan 30. Then you can plug that on your calculator and the height will simply be equal to 57.7 meters. So guys, this is one of the examples which you can use to come up with a given value when you are given some of the values. So this is the basic. So I'll slowly be going in details. So make sure that you subscribe to our YouTube channel. Make sure that you register with Excel Academy. So let's quickly look at finding the component of a vector. Let's quickly look at finding the component of the vector. So you need to understand that a component is the effect of a vector along other directions. A component is the effect of a vector along other directions. So we have two important components. We have the x and y component of the vector, and this can be illustrated by using the diagram below. Remember, this is the resultant, this is the angle, but this resultant has the x component and the y component. So the x component and the y component, they act at a certain angle to come up with the resultant. So let's quickly look at the illustration. So if you look at the same resultant we had, remember I've been given 40 meters, 40 meters, 40 meters. So if you look at that resultant we have, so this resultant, for us to have this resultant, it's because it has two components, right? It has the x component, which is that one, the x component. Let me just be a little bit slow there. The x component, which is moving from here, going this side, isn't it? So this is the x component, and then we have the y component, which is that one. So the x component and the y component are coming up with the resultant. So for you to find the x component, you use this formula, which is the resultant cos theta, because the resultant is simply the what? Is simply the hypotenuse, and then the adjacent is simply the x-axis. So for you to find the x component of a vector, you need to use the what? You need to use x is equal to r cos theta. Then the y coordinate is just y is equal to r sin theta, of which r is just the resultant component. So this is just helping us to find or to convert a polar vector to a rectangular form. Like we are trying to combine the polar one, then we take it into the rectangular coordinates. So remember, I first talked about the polar, which is having the resultant and the angle, and then I also talked about the coordinate, and now we are trying to combine the two to come up with one thing. Okay, with this being done, let me quickly look at two questions. So please make sure that you register with us and make sure that you subscribe to our YouTube channel. Okay, we have that question. A person walks 400 meters in a direction of 30 degrees north of east. So this is a very important question, and you guys should be able to understand every content of it. A person walks 400 meters in a direction of 30 degrees north of east. How far is the displacement east and how far north? So how far east and how far north? So this person has moved 400 meters, okay? This is the displacement in the direction of 30 degrees north of east. So this person has moved from that particular point to that particular point, and the angle which this person has moved is just what? 30 degrees. So if we consider this, we can come up with that free body diagram, or we can come up with such an understanding where the displacement is 400. So this is the displacement, which is 400. Then remember the angle here which we have been given is 30 degrees. Then the question is, how far is the displacement east and how far is it north? So in short, we are trying to find the x component and the y component of that particular vector. We are trying to look for the x component and the y component of that particular vector. Okay, so the x component is just the adjacent. The x component is just the adjacent and the y component is just the opposite. And the x component, we can simply look at x is equal to r cos theta. What about the y coordinate? The y coordinate is on the opposite side, and this guy is just y is equal to r sine theta. After we do that, let's continue and look at this same question. So with that in mind, let's quickly look at the same thing. Okay, so like I have said, the y coordinate, it is this one, which is the opposite. The x coordinate is that one, which is the x component. So we need to note that the x is the side of the adjacent to angle 30 degrees. The x is just the side adjacent to the angle 30 degrees. And for us to find x, which is on the adjacent side, we just say adjacent is equal to hypotenuse times cos 30. So this is coming from the basic which I've already given. And this adjacent, remember the adjacent is x. So where there is adjacent, we are going to put x. And then where there is hypotenuse, we are going to put the resultant, which is just r, and 400 in this case. So that means that x is equal to r cos theta. And then we need to understand that this resultant, okay, this guy, when you talk of this guy, you can just simply subtract where there is r, you put 400, and then where there is theta, you put 30. So you're going to have that, and when you plug in on your calculator, this will be positive 346 meters, 346 meters east. The positive sign is telling you the direction where this guy is going. Remember that coordinate, the coordinate one we talked about? So this guy is just telling you that we are going in the positive side, which is a plus 346 meters east. So because this is that. So because this resultant is for the x coordinate, we can simply write this to be we can simply write this as the x component is rx. Rx is just simply talking about the r coordinate of that resultant. Okay, remember the 400 was the resultant, and this rx is just talking about the x coordinate of it. Yeah. All right, what about the y coordinate of this same question? So you need to note that the y coordinate is the side opposite to the angle 30 degrees. So this is the opposite side. Okay. So for us to do that, where there is opposite, we are going to put y, and then where there is hypotenuse, we are going to put r. So when you plug in the values, you are going to find that y is equal to 400 meters sine 30. So y is simply equal to positive 200 meters north. So that means that the r component of that particular vector was just 200 meters. Okay, so one thing that we need to understand that the x and y coordinate of this particular vector or this particular question were both in the what? Were both in the first quadrant. So if you look at that, you need to understand that both the x and y coordinates we are in the first quadrant. If you observe very well, this is positive 200 and that is positive 346. According to what I've already explained, that simply means that these guys are both in the first quadrant. Okay, so in conclusion, according to what we have been asked, which is how far is the displacement east and how far north. So in short, the person is displaced 346 meters east and 200 meters north of original position, because 200 is talking about the north part and then 346 is talking about the the east part. So with this in mind, I can simply talk about the signs for rectangular coordinate. So you need to also take note of the signs of rectangular coordinate. So the information I'm giving right now, it's the basic information which we are going to apply on most of the exam questions, test questions. So it's very important for someone who has been exposed to physics, specifically when you talk about vectors, to know these basics. So let's look at the signs. So signs for rectangular coordinate in the first quadrant, r is positive. Remember, the resultant is positive and the angle is between 0 and 90 degrees. The angle is between 0 and 90 degrees, of which the x coordinate is positive and the y coordinate is also positive. Then when you talk of how you can find the x value, you can simply use the formula yx is equal to r cos theta, of which r is the resultant, and then y is equal to r sin theta, of which r is also the resultant. That's for the first quadrant. Then when you talk of the second quadrant, the signs, when you talk of the signs of the second quadrant, one, you need to understand that r is positive and the angle is between 90 degrees and 180 degrees. R is what? R is positive. This R is positive and the angle is between 90 degrees and 180 degrees. So you can consider 91, let's say 90.1, 90.001 up to 179.99999. All those angles, they are within the second quadrant. Okay, so when you talk of such angles, you don't really just start from there to there. Instead, we move from there to that point, like I've already explained. And then in the second quadrant, one thing you need to understand that the x value is negative, because this is the negative side of the x value, and the y coordinate is simply positive. So if you find that the x coordinate is negative and the y coordinate is positive, then that is telling you that you are dealing with what? You are dealing with the second quadrant. Okay, so that has already been explained. So to find the x value, you just simply use x is equal to r cos theta and y is equal to r cos theta. That's the second quadrant. What about the third quadrant? So the third quadrant, the angle is between 180 and 270. The angle is between 180 and 270, of which both the x and y coordinate are negative. Finding the values, you use the same way, which is x is equal to r cos theta and y is equal to r cos theta. The last quadrant, which is the fourth quadrant, the angle is between 270 and 360, 270 and 360, of which the x coordinate is positive, the y coordinate is negative. X coordinate positive and y coordinate is negative. So that's for the fourth quadrant. Okay, finding the coordinates, you just normally use the same thing. Alright guys, with this being done and me giving the summary of the vectors, so kindly note that this is my part 1 on vectors, and then make sure that you follow up and watch my part 2, which I will soon upload. So make sure that you subscribe to our YouTube channel and make sure that you also register with Excel Academy. So in the next class, I'll simply talk about the resultant of perpendicular vectors. So I'll be talking about these guys. So you guys should be able to follow up. You guys should be able to register and subscribe to our channel. Thank you very much, guys. This was Dr. Possibility from Excel Academy.